Live again. Great. All right. So next speaker is already on the stage. We have Siegmund Duell. Everybody calls him Ziggy, although he's got Siegmund. It was super interesting because we've got connected through the Siemens network, right? And we've just chatted about his challenges and how he actually thinks about implementing and producing new products, right? And he has a big challenge because he wants to bring AI into application. So we talked a lot about how do you produce MVP, and he always said like, okay, but MVP is actually not the problem we're having. Our problem comes after the MVP, right? So how can we get that into production, right? How do we get real value for the customer? We don't want the playing stuff at the beginning, like how do we bring it into production? And he is one of the entrepreneurs, like Sebastian just said today, like entrepreneurship is really hard. It's entrepreneurship, right? But still there is the antibodies in your organization who always wants to kill your idea, right? And we talked a lot about that, and I really could feel in which situation he was, right? Because of my entrepreneurship experience beforehand. And then the fun story was, like I knew he is really busy, right? In the evening, I reflected a little bit about what we talked actually, and I wrote down the description of his talk without knowing what he actually presents. Next day, I called him and said, okay, I scripted the description of your talk, said, okay, this is the title. And he was like, oh, sounds good. Okay, can I read the description? And he said, go ahead. I read the description. He said, perfect. I said, no changes? No, that sounds good. That's how I actually...
It was really spot on. So.
Yeah.
And you will see why in a second as well.
Okay. And I'm really looking forward him talking us through their development process in an incredible hard environment, B2B, in a corporate environment. And he will talk us through the steps they take and how they make that possible to be really successful with that. Give him applause.
Hey, thank you so much for having me here today. My name is Siggi, as I was already introduced. I'm heading a product portfolio team in Siemens digital industry that actually has an AI portfolio around hardware, software, and services for the industry. And more precise, mainly discrete manufacturing. That is anything from cars to pills, many different verticals. And I would like to show you today what we actually do to get products in this space, which is very challenging and complicated, as already introduced, with many players actually, because there's not only two Bs, but actually many Bs in many cases in there. And I want to take you on a journey to explain to you what AI is, very briefly, just to give you in a sense, show you the challenges that we have around their full topic, and then walk you through a few principles that we have built to actually take a product all the way to the market in a way that they actually can scale and we can actually bring it to our customers that we already have worldwide. I took any Siemens products out of that, so it will not be a sales pitch or anything, so you will not find Siemens products. If you want to know what a Siemens automation product is, you can Google this and you'll find all the great gray boxes that Siemens actually makes and puts in the automation equipment, so I spare you that. I think we also have a museum here, so you will also find some of that actually here at the building if you want to know what the Siemens automation portfolio in total is all about. So let's dive right into it. All of you might know that if you use your phone right now, or if you have any fancy camera at this point, AI is everywhere at this point. So it's built in whatever the Sony cameras right now used here for the autofocus, do eye tracking as an example. And it's doing an excellent job, anything that any photographer would actually have dreamed of some years ago. And now it's really easy to keep somebody in focus at all times. So something like this, or having AI in any sort of web application, makes the use of AI almost invisible and very natural to us. And also, it seems very simple to use AI at this stage when you go and build an application for that. However, what all of those applications have in common, if you think about any of them right now, is that the domain that they're used in is absolutely clear. It's crystal clear where the focus tracking on the Sony camera is used for, and it's actually dedicated and marketed as tracking your eye maybe it has a feature to track bird's eye, and then if you know the technology behind it, there might be actually multiple models or one model that actually is trained to be able to detect a human eye as an example. But it doesn't do anything else than that. And also in this case, the product is meant and built in a way that the consumer can use it for this one specific purpose, right? However, when we come to AI in the industry, you will soon discover that it's actually a whole different beast in complexity and what people do with these kind of things in the industry. When we talk about industry, we talk about a global market that is estimated to be quite big at this point. So it's actually having a tremendous growth rate in the last years, that we already seen, and it actually is continuing to grow quite a bit. So there's a very huge pie that we would like to get into, and also in this building at Siemens, we really would like to also be part of that. That's why we actually started to build an industrial AI portfolio and aiming to actually take both on the hardware side all the way to the service spectrum, a chunk out of this market to help our customers that are already Siemens customers for many, many years in the space of industry automation, and also start to adopt AI in solving their problems. Why would you want to use AI in the first place in industry? If you look at a shop floor, and again, I don't want to show you any pictures and spare you the time on Siemens automation, but you can actually picture anything that you might actually be familiar with that is like a car factory, and you can take the latest pictures you might have seen on TV from Tesla in Giga Berlin as an example, or any other car factory of that make. What you will see is that there's actually a huge amount of automation equipment all across the factory. So from where the car parts are stamped, from metal sheets that go into a press, from the conveyors that actually move car parts around, from the paint that is put on a car, from any of the test steps that are done in between any of that, you will find automation equipment. And you will find a lot of automation equipment that also Siemens is making. And this automation equipment is actually used in all of these steps to solve problems that are there repetitively in many cases, and very predictively done with standard classical automation that has been there for decades at this point. So it helps to remove error, it helps to get this incredible precision that we have when we make cars, and it actually helps to do this at a very, very tremendous speed. However, there's many, many challenges that you still have in the case of automation when you come to actually a more flexible production. We don't need to talk about lot size one, you even need to just go for something that is harder to automate because, again, the material is difficult to handle, like a diaper and not a car, as an example, or the material has any other properties that actually make it much more unpredictable to actually process. And then you actually very quickly go into a situation where you would, again, need a human worker to do something, because, again, it would require the precision of a human worker right now, or the intellect of a human worker. Or actually, it's something that is simply too diligent right now to actually do with a robot or with anything else today. And then you would actually end up with an automation problem that is either a huge engineering challenge, or, again, if you have AI, you can actually solve it with something that actually can learn. Before we go into some examples, and I'll have some slides as well about that, let's just look quickly about the main challenges when we look at a problem in general that we see when we adopt AI in a factory. One big thing that one needs to see when you talk about a car factory, you talk about anybody that works on these car factories. And if you're not in the industry, the players that you usually would have at a car factory is Tesla, like having the car factory. You might have actually people that build machines that go into this car factory. You might have system integrators that connect these different machines to a line. You might have solution providers that actually on top of the line add something around quality assessment for each of the stations. Then the list goes on. You might have companies like Siemens that provide automation equipment like motors and control panels and controllers and computers and such. So there's many, many different parties that actually come together when a car factory comes together. But what all of these companies for the manufacturing have in common is when it comes to skill of staff in this case. So of course Tesla, if you think about a different domain like making autonomous cars, right? You think about AI there, that's a very different beast. When it comes to all the companies that I just mentioned, they usually have electrical engineers, they have mechanical engineers, they might have some automation engineers, but most of them are no computer scientists at all. So they don't have any of the skills needed today, if you think about AI, and anybody of you have built any AI product, to actually tackle anything with AI. It's completely alien to people in the engineering space. So they might have used it on their phone, but they cannot translate this to anything that would actually make sense on the shop floor. So having skilled staff is a huge, huge topic. And that's actually also one of the reasons why we at Siemens believe we have a very good shot at getting AI in the shop floor, because if you look at any of the tools right now they're all made for the computer scientists today. So one big thing that people see, and you can actually go read later on if you're interested in some of the stories you find when both Siemens and Amazon, for instance, work at Volkswagen, which is you find much of that actually in the public. There's a lot of also Siemens colleagues actually ask, why would we actually go together with Amazon in the factories at Volkswagen? And the answer is quite simple, because we are doing the OT side of things. So we are not trying to compete with Amazon and building AI, web services, or anything that you can actually use on the cloud side to do AI. That's not our business at all. But there's actually a huge challenge to get this to the shop floor and to the workers that actually work with building the cars, for instance, every day. And that's what I would like to show you today. And there's one more challenge actually that many people, again, when we talk about the eye tracking on the camera or again making the cars, they don't have actually in mind when it comes to AI. And that is that AI in many cases actually needs to be stable and needs to do what it actually supposed to do. Again, when we have the eye tracking on the camera, it's very simple, because again, it's meant to just track the eye, and the human eye is looking the same today and it will look at the same 10 years from now. People may age, but it needs to work on any age group anyway. So there is no degradation on the performance of the eye tracking. You can test it today and you can ship the product and it will actually perform indefinitely, as long as the camera is not breaking down, of course, or any of the sensory equipment is not dying. But there is no reason why the model should actually not work anymore. However, if you look at the car factory as an example, it's a very different story in many cases. And one reason is just, I don't know, you think about Volkswagen again, they make a new car that looks different every day. Tesla is a little bit different, right? But even there, the variations on the product is quite high, and things actually constantly change on the line because it's optimized to actually have new parts, better parts, cheaper parts, change production procedures, shuffle things around, and the things that AI should do, in many cases, actually needs to adopt all the time. So having an approach for machine learning operations that allows you to actually keep AI where it's supposed to be is absolutely essential. So this would be the same as if you would have a Sony camera, and the Sony camera would actually be required today to detect human eyes, and tomorrow we want to have the same system, but we want to have, I don't know, from a beetle, we want to do eye detection for the beetle, but again, it was never trained to do that, and now the camera operator actually can request on the Sony display to say, I now want to detect the eye of this beetle, and I can teach the camera right now to do that right now. And I want to do this with a precision of 99.9% all the time guaranteed, because otherwise I get shot by my quality officer, right? So Sony doesn't have that problem because, again, the photographer guy doesn't have somebody that will actually do quality control on how many pictures are sharp and in focus or not. But again, in a factory you do have that, right? And the Sony system will immediately be kicked out if the quality is not there and up to par, and it will degrade again. You will be out of the business. So in this case, it's not only building the system, but actually keeping the system at the quality needed is a huge, huge topic. So that's something that most people that actually build a first application that actually has anything to do with data might be able to sing a song about, because again, there's a lot of instabilities you might have and a lot of problems that actually arise from having not only something that works with hardware, like you have an AI that's always running, in, at least for us on the shop floor, something connected to some physical world, but it also has to do with something that actually changes all the time, which is data and the procedures that actually derive data on the shop floor. So I briefly touched about that topic, but I want to emphasize this again, that the biggest difference and the biggest challenge that we see when we do AI in the industry is that it's not for a computer scientist or for an AI engineer. So if any of you have any contact with a computer scientist, they might be able to tell you and build, even if they never heard about AI, build an AI application in a day or two in a hackathon. It's super easy. For anybody that has some skills in this, it should be very, very straightforward to do. However, if you get the same person and you put it to an automation engineer, and you give him the tools that an automation engineer has every day to work with, like the TIA portal from Siemens is one example, I'm almost sure the person would not know where to start with the tooling, because it's such a different world. There's no Python, there's no scripting, it's a very different starting point. So it's I don't know. It's very difficult to translate here. But the point I would like to make is that when you do AI and you look at any of the existing AI products that you can off the shelf immediately find, they are not meant for industry in 99% of the cases. So there's a lot of AI that you use there. And again, I used some examples from AWS before. Any of those examples would not appeal to an automation engineer or to a process engineer that is actually tasked to actually make some use case work on the shop floor. So that's a huge differentiation. And that's something that also Siemens actually had to learn the hard way. So we had quite some failures when we started to make and get AI also on a fast path for our applications, because we completely ignored the fact that automation engineers have very different requirements. And uncovering all the personas that are running around on the shop floor that actually interact with your application is a huge topic. So, and this is actually a big challenge for many that do work with such complex domains in the B2B, because as we soon uncover, there will not only be one type of persona, the automation engineer, which I just used here, versus the data scientist, but actually a very complicated factor that this automation engineer might actually be from many different parties in this game. So we might have actually many different stakeholders that send automation engineers to the shop floor at like Tesla, that actually makes making a business out of this even harder. So now we have seen a little bit about what AI is. Again, most people already hopefully have seen or understood the examples I gave with the Sony camera and eye tracking, or actually have heard about Tesla Autopilot or anything. So I hope that topic and concept is clear. What I would like to now do next is I would like to show you 5 principles that we have to uncover AI in the industry and what we really believe is absolutely essential for us to make products that actually at the end of the day are worth to ship to the market and also put the money in. So today we had one question around what do we do with our stakeholders and in the management to actually make a product work, not get overloaded with reporting and such. And I'm pretty sure that if you follow the first principles that we have here right now, that you will also have your back on the management side quite a bit. Because one thing that we see, at least here at Siemens, is that if you actually are stuck in a reporting loop, and in many corporates you might have that actually, one way out of that is actually to be extremely proactive about that and also understand the position of your management there. Because again, in many cases, especially when it comes to product development and some eagerness to understand, it's really mainly a lack of understanding that one transports. And if one addresses really the concerns that you have of your investors, in this case, your corporate management, then again, it's much easier to actually get also some leeway when it's actually clear what you're doing there. So let's just start with our first principle that we have. And for that, I would like to show you a shop floor as we actually have it at Siemens. And actually, I show you 2 versions of that shop floor. So this is a standard electronic factory as we have it at Siemens, which is also one of our secret weapons when we start to do AI actually, because Siemens actually has own factories. So that means for us, if we want to do AI, we can go to our own shop floors. And for the sake of this presentation, I will actually show you examples for electronic manufacturing now, because again, I can show you quite some things that are also public, but actually out of our own domain. And it's actually makes a very important point. And that is, if you want to do something like this in such a complex B2B environment, you better have very strong partnerships. And you actually start in the domain in an area where you actually have relatively short life cycles and where you actually have full access to whatever you're doing here right now. So I would see it's really hard for anybody that has no access to this domain, no access to the shop floor literally, to make a product that actually makes sense at the end of the day, because of that complexity that you have with respect to different players on that shop floor. So this is a factory that even offers visitor tours. It's in Franconia. It actually is the lead factory for making some of the automation equipment, mainly power supplies that we actually do. So power supplies are very complex pieces of equipment because unlike an iPhone PCB, there's also very big pieces on there. And these big pieces are also very different procedures that you use to actually make those PCBs. And in order to have such a factory with these lines in there, you actually need to do what we have for most of the applications when we go to AI. We need to deal with many different parties here right now. And parties, I mean, all these machines are meant by many different manufacturers to make a line. So we have a machine that actually puts SMT parts on a board. That's one manufacturer. Then these PCBs are tested by a machine by another vendor. Then after this, actually, it's soldered on by yet another vendor. And after we have soldered the machine, again, there's other testing, yet by another vendor. And the story goes on like this. So we have worldwide a set of, in the ballpark of 100,000 SMT lines. But if you just look at one piece of equipment, like a test equipment, that we'll see some examples later on, this market is fragmented where you have at least 10 big players that actually make the market, and that's the easy part. So some other areas where there's testing done, you actually have, in China alone, 100 companies easy that actually are even on a Siemens shop floor in a single factory, if you're not careful. So it's very, very fragmented market. And that leads to a lot of problems if you want to do AI again. Just coming back to the Sony example, but just having the eye tracking work not only on a Sony camera, but also on a Nikon, Fuji, or whatever camera you want, may be quite difficult because you might not know what's there and who even lets you to get even the data out of the camera that you would need to make such an application. So what we see here, in translating this to an electronic factory, is if you make any use case, it's super hard to even find a starting point here, what is actually possible. So this entire factory is full of Siemens equipment, but where can we now start with a use case? Where and what can we do to actually figure out where is the highest value we can generate with AI? And of course, what we do is we go talk to our people on the shop floor, and we find a lot of use cases, and we find a lot of use cases that are really great, that make a lot of sense. However, when we dig deeper, for most of these use cases, we actually find it's super difficult to actually monetize at the end of the day in the market. I will show some more details about that, but one method that was also mentioned in the previous talks that we use here is working backwards. So really starting with the end in mind. So any use case that we do actually, we of course want to make sure that what we actually have here at the end of the day creates value for the customer that is there. In this case, somebody that would actually operate a factory, or actually a machine in this factory, or actually somebody that would build a machine in this factory. So here you already see the customers that you have potentially for a product is actually not one, but actually multiple. Because if you look at such a factory where you have just a testing machine in there, this is meant by a different player than actually the factory builder itself. So here, one big problem that we start to solve first is who is actually the customer right now for us in this B2B environment, because we have many Bs here right now, making the machines, making the factory, or producing a part may not be the same party. So that's really one of the first challenges. And by working backwards, and again, this is a great book from Amazon, actually, some colleagues out of Amazon. I highly recommend that book if you have not looked at that. We actually are able to very quickly understand which use cases actually are useful in a general sense, so which ones actually create value. And we continue after we have understood which one create value. We create with those the next steps, but only if they actually have value. And as I said earlier, if you have such a complex factory, there's so many possibilities there. And actually a lot of working students and different parties, third parties like startups and such, they come to us and they want to test and try use cases and things they can actually solve. And with all of them, actually, when we work with them, working backwards is our method of choice here, to actually find use cases that actually create value at the end of the day for the factory, in this case for us as a customer, but also putting ourselves in the shoes of these different players that actually are on the shop floor. And just to give you one example now, a concrete example of our factories, what we do there is AI in testing. So after looking at many different tests that we had in the factory, because actually not one test, there's actually different things tested, we found that particularly one concept of in-circuit testing is something that would actually scale. And by having this use case factored and tested and validated in this first factory in Germany, and really going the hard way and understanding how we can actually solve this problem, we have been able to bootstrap the essentials that are needed that we can actually make a use case that is actually creating value. However, we don't stop there. If you have now a use case that works like in-circuit testing, that's a use case where you have multiple components in there. Again, I will not go into detail what is needed for any of those AI cases. But what you will see at the end of the day in the next step is, if you do a use case and you try to sell it as Siemens, it's expected that we make actually impact with this very, very quickly. So Siemens has a global sales force in almost any country in the world. We have a few thousand salespeople that have access to all sorts of domains and all sorts of verticals. We have an own vertical sales in electronics. So if we now make a use case for in-circuit testing, one of the first steps that we actually have to go to, and that's one of the go, no-go criteria very early on with the management, is would our sales that we actually have, our sales channels that we find for this topic, actually even sell it, right? So before we even start building anything that is more than a POC, we actually check out if we can actually go sell that. This sounds extremely trivial, but I can assure you, in this company, a lot of products and a lot of innovation and a lot of technology has been built which solves great problems, which creates a lot of value, but Siemens is not able to sell. So there's a tremendous amount of technology, which is really awesome, around this electronic manufacturing and not going even in any other domain, which is completely useless from a monetary perspective. So going back to your stakeholders at the beginning of the day, if you build a great product for your management, they might not even understand that there is a problem down the road that you cannot sell it. Yeah? And there's many reasons why you're not able to sell it. So one is you don't have an electronic vertical. That would be very obvious, right? But even if you don't have electronic sales, it doesn't mean that your electronic sales has access for the kind of area where you need to have access to. Concrete example here, Siemens has a great electronics vertical, and it sells mainly power supplies and other things for actually companies like Foxconn and other makers of electronic equipment that you might know that actually make all the iPhones and other things here, right? And Siemens has access to those companies. However, for us, it was actually quite a stretch to find within this vertical countries and partners that have had access to the domain to do the testing on those lines. Because just having an electronic vertical in a big company like Siemens still is actually too big to address a micro vertical, in this case for SMT production and testing in this small part of electronic manufacturing. So having really early on figured out how to go to the market and ensure there is market access and having all the means available, even a big corporate like Siemens, is absolutely essential for success. And of course, there's other ways, so I don't want to go there, but from a portfolio perspective, we stop there if it doesn't work, but of course, Siemens can monetize ideas in other ways, sell it, ship it, go to Next 47 or anything like that, right? But from a core portfolio and product management perspective, this is an absolute no-show for us if you don't have access to the market for a given product. It sounds extremely trivial, but again, trust me, we killed actually 50% and more of the things that we did in the last 18 months because of market access. Yeah? The second topic that we actually also look after having a topic that creates value and something that we can sell is that actually it's in a niche that we can validate, and this niche is actually not too big and not too small. If you now think again about the factory that I showed you, that is so complicated that I could talk a full day about how many things are in this factory. The question is really, what is the right niche for an AI product? So if you go for the camera that has one AI model to do the eye detection, that's an extremely small niche on this camera, right? When we have an electronic production with a line that makes PCBs, so printed circuit boards that has components on them, and we look at a test stand, for instance, the question is this niche big enough? For this test stand, in-circuit testing, as I showed this use case earlier, one can solve the problem. For this in-circuit testing, there is value. Customers like it, one can actually sell it. But is this really still a niche for us that is interesting from a Siemens perspective? And that's a very difficult question, again, indeed, because even if you know that there's some 100,000, between 70 and 100,000 lines for electronic production out there, as you can find if you purchase some reports, and even if you Google a little hard, you will find some more details about that. The problem is in the detail. These 100,000 lines, again, are addressed by many different manufacturers for these niches. So you have an extreme fragmentation on the market for the machine builders that actually make the in-circuit testing machines. And all of them have different data protocols. Some of them are not even open. So even if your product is great for them, but just getting access to those guys is really, really difficult. And then you still have the question, do you address it with the manufacturers of an in-circuit testing machine, which is one option to actually go to the market, Or do you go to an electronics factory, as we did with our own factories in Erlangen, to actually sell it to somebody that operates an SMT line? That's a very, very difficult question to ask. And here again, of course, since we have the factories, we have a very big advantage. We actually can go to our own factories. We can see what's in there worldwide. We get a very good sense of what actually is there, because we have dozens of factories across the globe, in China, in Europe, in high-cost countries, low-cost countries. So this gives a very nice sense for us where and how actually things are put together. So we can not only understand that there's a use case that we can solve that is value, which gives us an idea how products need to be shaped to actually address this use case, but it also gives us an idea which of the Bs that we talk to, which of the businesses that are there, are the right ones for us to address to actually get in the market. Because at the end of the day, as unfortunate it sounds, and also very hard lessons that we learned, is we can solve great problems in this space. However, if there's a lack of understanding, or actually a risk that like a player like a machine tool builder, or in this case this in-circuit testing builder, sees a threat in Siemens, that we would actually take a use case that they would like to monetize because they see this as in a no-fly zone, then again we will not be able to successfully market that product, even if it creates tremendous value for the factories that we have and other people also would have. There's no way to actually get anywhere. So by finding the right niches in this case, being not too broad, because again, the case might depend on the data that is there and the formats that are there, and even electronic production is quite standardized. Trust me, all of the machines have different formats, and converging this to one format we're working on very hard at Siemens, but there's still a very, very long journey to go to, is one of the very, very important topics to do that. And out of these electronic production cases, we see that we have scalability for individual cases, which are in the 5 digits easily for just one application. And out of this, actually, what we do, and we start with something like in-circuit testing, indeed. But then we can actually take these applications along a line, and we then can multiply by just, if you have 3 or 4 test steps, as an example, you can actually have very nice economies of scale, even across a line, and even in this very narrow domain of just one vertical where we go to, that is electronic production right now. So if you step a little bit deeper in electronic production, and here's just this typical SMT line again, what we see is that we have a line that consists of these multiple elements of machines, as I said earlier, putting pieces on a printed circuit board, soldering them together, and then testing them. If you look at this topic of data, and I mentioned this earlier, that the machines generate different data, even the problems that you solve are very ambiguous. So they're not the same all the time. We have this eye tracking from the Sony camera as an example before. It's always a human eye, and it's always the same. Here, again, if you look at these electronic components as an example, they actually change over time. So there's, of course, many different components that one wants to address. And at the same time, there's also many different failure modes that one actually needs to address. And here, the validation that we need to do in these niches is extremely important, that we actually don't overdo it. So we actually go in the niche, but you can very easily overfit and actually spend way too much time and effort in building something that will never generalize, because you just optimize for a PS5 PCB as an example, which will not go anywhere. So here, also looking at startups right now that we work with, it's extremely difficult to actually have solutions that come out of this niche again. So just showing you that as an example, that one actually does not get stuck too deep in applications that would otherwise never come out of something that actually can scale. And that's really, at the end of the day, what Siemens needs to do. We really need to be able not only to address electronic production and manufacturing with the products that we are building. At the end of the day, Siemens automation equipment is going in all domains. I started with the cars, and we looked at the electronic manufacturing, but the products that we're building, they need to go into breweries, and they need to go into the car manufacturing, and it's actually the same pieces of hardware that they put there. We put the same pieces of software there, and we apply the same services there, whether it's a diaper or a car. So the last step that we do in our innovation cycle is that after we have gone through all of these steps, creating these use cases and having those use cases, many of them done with partners or even customers that create value, understand that we can actually address this from a Siemens perspective in the market, that we have the sales channels to those. That is either very big vertical accounts, this is actually partners within the company, because Siemens also has like a software business as an example. So we work with our software colleagues quite a bit to actually sell in other channels. We also go through third party, like a machine builder to actually sell through. So after you have found all of those, the next step is that we actually scale this and we break it down into product components that we actually can sell across the board and beyond as individual use case and vertical. And that seems like quite a stretch, but when you actually go through this cycle many, many times, as I showed earlier with just this one example of testing, you actually find some of the common problems that we as Siemens, in this case, try to address to actually create these scalable opportunities from a product perspective. So just taking again is one domain which has this key topic of data. I think somebody on the audience also mentioned this, right? One of the key issues that we see here is the data access is extremely different between the different stations in an electronic line and also different vendors in an electronic line. So standardization here plays a huge role. And what we right now do is we prepare both, of course, the standard right now. So we try to set and influence the standard and influence products that help us to get the data in a consistent fashion. At the same time, preparing the products that are required to get an AI model that is not only detecting human eyes, but in this case, detecting failures on a PCB board to these lines in a way that they actually can be operated and maintained for many years on a production line. So when we ultimately look at the topic, what we do is we break it then down into individual products that only address what we need to do as Siemens, and that is on the automation space, do only the part where Siemens can actually make money with, and Siemens is able to sell it into the market. If you look at this picture right now, so this is actually the core ideas and the core parts that we arrived making a portfolio from. So of course there is a big hardware portfolio. So Siemens has a big hardware portfolio already, and what we actually started to do out of all these use cases to understand which hardware components actually are required for AI. Some of them are just also standard portfolio, which is non-AI business, but at this point you will find quite some hardware actually that we do dedicated for AI. And having a software portfolio that is only addressing the challenges that we have on the shop floor, for instance, while partnering with big cloud providers on the cloud side of things. And all of that having into account that it actually can be maintained and that we can actually operate those AI models for an extended period of time, and working with big companies right now for actually operating their AI models as a service, so that if you have a factory like Tesla, or you have actually a factory like Procter & Gamble, where you have hundreds of different plants and lines, and helping them to operate those AI models that are there for actually an extended period of time. So with this, I would like to close. So these are the 5 principles that we actually have. That is, we only focus on use cases that create value, which sounds a little bit strange, but if you do AI in a corporate, there's also another reason why you want to do AI. And that is actually in many cases, AI is also done today. I would absolutely stand for that as a showcase. So many companies, big and small, do AI just as product marketing. So we don't do that. So we do AI to actually create and solve problems that really have a meaningful impact. And it's a pure AI product. It's not a marketing slide. This might sound a little bit extreme, but there's studies that also in the German startup space, a lot of companies actually just do AI for marketing purposes. So that's really important. So creating value with AI is very important for us. We focus on the market access. So again, from a B2B perspective, this is extremely complicated. It's not so easy to understand what the market is and actually where we go to. We try to understand also within this market what our personas are. We try to understand that we can find a niche within this market, so we can slice it, dice it, so we can scale finally in the last step out of a niche. And this step, again, ends up with our portfolio that we now have built in the last years. So I will not bore you with any of the details of the portfolio, because for this you would go to a dedicated fair SPS or go to a Siemens presentation. Thank you so much.
Thank you so much. Thank you very much. So, I listened to that, and when I work with startups, or entrepreneurship, we always had a heuristic, typical way to process, and that was first, who's the customer and what's the job to be done. Second, is our solution the right one? And third one is, can we access those people is the channel the right one, right? And that's all towards the market, right? Basically, you described the same, but you described it in a little bit different steps, actually. And I was wondering why you really, it seemed like you really do the third step, which we typically do, like the channel, at first, right?
Yeah.
Is that correct?
Yeah, absolutely, because we have channels. So the answer is simple. We have a lot of sales. We have some 1,000 sales reps and a very big sales organization. So if we really want to be quick right now in the market, trying to build a new sales channel for us, this would be incredibly expensive and hard and very, very cumbersome to do, and not even in our powers at times, right? So but in this case, by tailoring the products to the sales channels and what they can do right now, makes total sense from our perspective.
Okay, so you first limit the channel, then you look at the pair customer value, right? Do you get a niche?
Exactly.
You called it niche.
Yeah.
Customer is just a niche, right? And value is, okay, do we have the solution, the right one, right? So you work backwards, right? So channel, yes, and then niche and value and combine that. Yeah. All right, thank you. Questions? Who has questions? Let's throw the... Zack.
Hey, thanks a lot, Sigi.
Hey, sure.
So I understand that by having very practical applications, it's more low to earth. Like it's a more understandable product that you're building. But is it still difficult to manage expectations across the company, especially for people that don't know about data science or AI?
The expectation is difficult in two ways, right? So one is that to manage expectations towards how capable and how far you can scale or generalize AI. That's a big expectation. So some managers still believe it's like easy as making a green button and you click here and now it works for the car and now it works for the electronic production like that, right? That's still an issue. So this is actually got resolved in the last years quite a bit. Also management learned that it's much harder and actually generalization is a very big research topic still, right? But that's the easy expectation, I would say, at this point. Like managing technology expectations is easy. The hard one is really to adhere and to the investors to really make the numbers that are there. So the market is huge. If you really look into the details of those studies, you also will understand why the market is huge. But for us right now in these automation domains, really carving something out of this market now and quickly, that's where we're really challenged on. It's really like, can we make the numbers right now while building a new product portfolio, literally from scratch in the last years, out of a lot of technology that's already here, and really making revenue and getting the organization to be leveraged, like the sales organization to be leveraged. That's where we're challenged on. Like, we have all these sales channels right now. Why are they not able to sell more of AI topics? And of course, they are not ready in some cases, right? So we literally dumb down some of the products so that sales channels can take it today. No offense if there's any salesperson here right now, but it's really it's a big challenge to meet the corporate expectation with a topic that is so vastly different from what Siemens did before with automation equipment to meet the expectations in terms of product impact and revenue.
So it's also typically hard, like if you have like a huge ship like Siemens, right? They come with 100 billion revenue in year. Yeah. So you come up with an idea and say, okay, this will make 2 million. They just, love it, right? So can you share how big the opportunity needs to be in order for Siemens to say, okay, this is interesting? And how do you deal with that? Because typically, innovation is not that you have a huge revenue at the beginning, but, think about digital cameras, right? 30 years of progression, and then, you have the hockey stick. So how do you deal with that, and what size do you target?
Exactly. So what I can tell you about that is a few things. One is, a lot of the AI cases, when we talk about value, it's also, of course, about a Siemens value. So we have actually targets on EBIT and profitability, and this will kill a lot of the ideas. There's also expectation on timing right now. So some of the things, and we had like Boston Consulting and other parties here, they tell you certain businesses simply take, dedicated period of time, right? But if this is not in the corporate expectation, we cannot start with something like that. So we really need to tailor it to our corporate guidance, as was raised at the very beginning. Is the boardroom happy with what you're doing? You should rather check again on the other side with the question, what is your minimum expectation that you can actually give leeway in all these dimensions on the financial side and the timing side to actually start. So yes, there's very clear goals on profitability and also on impact expectations with respect to either strategic goals to defend a certain market or actually push a certain technology at a certain point in time. And that actually determines also that we, for AI, not only do hardware as an example. So we tried hardware, and hardware on its own would actually not be enough right now. Why? Because the market is not there yet right now. So many of the system integrators, they need tools right now that they can use so they can actually do something with our hardware. So we really need to also help in this case to create some demand. So there's a lot of strategy at play here right now, also with other Siemens products that we actually run with, that we actually need to adhere to from an overall corporate strategy.
Who else? I think somebody over there had a question.
Yeah, first of all, thank you so much. I mean, my head is like smoking a bit now because it's like it's a super complex field to get into. So maybe I just pick one question. So because you are working backwards from the sales channels, do you have any idea how much opportunity you are basically like throwing away in the sense of like do you have an idea in size? Because I would imagine like the kind of thing and the kind of use cases you uncover, like a lot of startups or a lot of like teams out there would be more than happy to take that opportunity and try to create a new sales channel around it, right?
And we don't throw them out in the sense that we don't try to leverage the technology or the ideas or whatever. So there's many products that we actually then ship in other places. So it's not that we simply cannot have in a product portfolio, right? So that's like if there's great ideas there, then we simply don't invest from our budget and report to our boardroom that we have now a great product that makes all the numbers, but we cannot find somebody to sell it right now. But the opportunities that we have from it's a big number that is shipped to the outside. So, but it's a deliberate decision. So strategy is also what not to do, right? And building a sales channel right now could be another strategy. We could actually say, okay, let's just take other products and invest in making the sales channel smarter at Siemens. We actually do that as well, right? To some extent, but that's a deliberate decision, of course, right? And it's again, the number is huge. Like 50% of the portfolio that we removed last 24 months has been to sales channel. It's actually because one of our earliest filter. It's really big.
Crazy. Thanks. It's like that's super interesting.
Let's see. Last question. Where's a question? No. Oh, we have a question. One more question. Why?
Thank you for the presentation. What I'm always asking myself, how many resources should like a big company like Siemens actually invest in new ventures? I mean, of course, no numbers have to be given, but like for other companies, what would you recommend?
Maybe let's break it down to the AI field, right? Because the total is...
So we had actually some side discussions on these numbers already, right? So this again depends really on some of the strategic situations that you're in, right? For the organization that we're in digital industry, there is a topic like IT/OT convergence, and you can read on that topic, and that has a lot of strategic implications for Siemens. Because it will change some of the hardware business potentially away to more virtualized systems, as an example, and that is seen as a certain threat to some of our revenue streams. And because of that threat, with some very smart consultants, we came up with some numbers what should be invested in certain strategies. But as we already had in a side discussion, I don't believe that there is any defined answer that you can give percentage numbers or something like this, because it really depends on the strategic topic that is there. If it's just a pure game of survival, then you would go all in on that topic. It's really very, very specific to the situation, I would say.
All right. Thank you very much, Siggy, for sharing your... Thank you for sharing the corporate, your insights from the corporate, and I really need to say once again, it's a really tough environment. Like when you described the shop floor, I was really like, okay, now lost me a little bit because I think it's really complicated there, and B2B is hard, and being an entrepreneur is really hard. So thank you for sharing.
Yeah.
Great you've been here.
Hey, thank you so much for having me.
So I think we are back at 15:45. Let's check again for our last talk. Exactly. No. Brand 16:30. No. I think that's wrong here. Yeah. 3:45.